Hello students, my name is Dr. Cynthia Parrish and I want to help you today learn how to test the minerals in your mineral kit. Starting with the lab manual that all the students are required to purchase for this course. Let's look and see what it's supposed to look like. So this is the cover of your lab manual and you can see it says Laboratory Manual in Physical Geology, has a picture of a road cut on the front of it and it's written by Karen Woods. You can look on the back of it and find the ISBN number and match that up with what's on your syllabus and make sure that you have the right edition and the right lab manual. So to use your mineral kit, you'll also need, and I've got the supplies out here, you're also going to need hydrochloric acid, you're going to need a nail, you're going to need a magnet, and a penny, an older penny will work, and this is the streak plate that comes in your kit. I have a small piece of sandpaper here that I'm going to show you how to use in just a moment to get the streak in case you don't have a good streak plate. Okay, and I have some other supplies out that we're going to look at in just a moment. So the other thing that we have is you need to make sure that you have safety glasses so that whenever you're testing the minerals that you keep your eyes safe and that you don't flip any of the splinters or anything up into your eye or getting the hydrochloric acid in your eyes. We'll make sure that we have good safety practice. So I'm going to put these on and then we're going to go through the step of testing the minerals. Okay, so the first thing that you need to do before you test your minerals is to make sure that you have read Chapter 1. So our video today is only going to cover Chapter 1. You can see as you go through your lab manual that you have 10 chapters to cover. We're only going to look at Chapter 1 today. So make sure before you do the mineral pre-lab that you've actually read all of Chapter 1. Use Chapter 1 to help you fill out this mineral pre-lab and not using Google or some other source, but actually using your lab manual to fill this out so that you make sure that you have the correct answers. So as you go through Chapter 1, it's going to explain to you what physical geology is, what an actual mineral is, and what native elements look like, and polymorphs. You have some charts that are in your kit, in your lab manual that are going to help you identify your minerals that you're testing. So this table 1.1 is chemical compositions and classes of common minerals. As you go through the chapter, it's going to show you pictures and give you lots of descriptions to help you identify your minerals that are in your kit. So as we work our way through, it's also going to talk about crystal habit and fracture and cleavage. Here's another chart on page 10 that goes over the crystal habits for the minerals. On page 13, there is a Mohs scale of hardness at the bottom. Make sure that you memorize that. 10 is diamond, which is the hardest, and all the way down to 1, which is talc. And you're going to use those also on your chart for your minerals. One of the things that we're going to talk about is striations. Also color, which is probably not the best property to use to identify minerals because it's affected by the size of the piece. It's also affected by any impurities that it has in it. So that's the least helpful mineral identification property, and you can't rely on that because fluorite can be purple. You can have other minerals that are purple also. So make sure that you realize that you have to do a little bit more testing whenever you get to that point. Okay, it talks about luster, streak, magnetism. That's what our magnet is for. And here's another chart on specific gravity. Double refraction. It's got a very good picture of double refraction in your lab manual. So if you had an optical piece of calcite, you can see this double refraction where if you put it on top of a printed page, it's actually going to show you that same word twice where the light comes into that mineral, and it's going to refract the light and split it so that you actually see the word twice. So that's through double refraction. And then the reaction to hydrochloric acid, which we're going to look at in just a moment. Here's another chart on the hardness ranges for your minerals. And then we have the description pages, the mineral properties and uses of each of the minerals. If you have a mineral in your kit that is not in the lab manual, you'll need to use the internet for those. Now, we get to the diagnostic tool and safety information. Again, we have our safety glasses on, and make sure that you're reading through all this information and that you're being very safe. Make sure that you're not eating while you're doing this, because you don't want to contaminate your food and you don't want to swallow any of the particles of the minerals. Also, after you get through testing your minerals, make sure that you're washing your hands good with warm soap and water and get any of that off, and make sure that you keep yourself safe. Keep the hydrochloric acid out of reach of any children, and again, make sure that you have your safety glasses on. So as you go through this mineral identification exercise, it says identify the unknown mineral samples provided, record the results on the mineral data sheets, do not leave blank spaces, and make sure that all of your mineral columns have been numbered. In other words, mineral number 1, and we'll go through there. I'll show you what we're doing here. So it says begin by recording the physical properties that are visually evident, like the crystal form, crystal habit, diaphaneity, striations, cleavage, that kind of thing. So let's take out a blank sheet and we'll look at that, and we're going to grab sample number 1 and we're going to look at it first. Get a little bit closer. Okay, so here's sample number 1, and we're going to look at it. And the first thing that it says is crystal form. I don't recognize any crystal form here, so I'm going to get my pencil and I'm going to look at this. It says crystal form, describe if present, if not, put an X. So I've done that. Crystal habit here, and I've looked this up beforehand for this particular mineral. And it says it's subhexagonal. So I'm going to fill that out. And luster. So is it metallic, submetallic, or non-metallic? And as you can see, this is very shiny. So this is going to be metallic. So I'm going to put a check mark here following the instructions. The streak color. And I'm going to take my mineral. I'm going to hold my streak plate flat against the paper, and I'm going to take my mineral and streak it on the streak plate, and I can see that it is dark gray or black. I could also use the sandpaper, and if you look, it's going to give me a streak that is, again, dark gray or black. So I'll put dark gray. Magnetism. So we're going to get our magnet, and our nail is attracted to it because it is magnetic. We'll get our mineral that we're trying to identify here, and we're going to see if the magnet sticks to it. It does not, doesn't pick it up. So if you look here, it says ferromagnetic, paramagnetic, or diamagnetic, and this one is diamagnetic. It doesn't exhibit any magnetic properties. Specific gravity, and I'm going to look on my chart for that, and I'm going to see that for this mineral, which I'm thinking is probably graphite because it's so soft, the specific gravity here is going to be low or lightweight, and the number scale is 2.09 to 2.23. And I wrote on the top of my paper from the lab manual that low is 2 to 2.49, normal or medium is 2.5 to 2.9, heavy is 3 to 20, gold is one of the heaviest at 19.3. So I found that an interesting fact. Diaphaneity, which is one of the things that some of the students are having difficulty with. Transparent would be like our magnifying glass here, which is very see-through. I can read through it. There's no obstruction for the light passing through it, so it's very clear. So that would be transparent. Translucent would be like our mineral here, that it's not quite clear, but you can still have light pass through it, and so that is going to be translucent. And then opaque, which is what Our mineral that we have here is, because light will not pass through it, it's very, the light won't pass through it. So we're going to put opaque. Now then, we're going to check and see if it reacts to the hydrochloric acid. So I'm going to take my acid and I'm going to place 1 drop on my sample. It does not react, it just kind of sits there because graphite is a little bit waxy, so it's just going to kind of sit there on top and not soak in like it would in some of them. You can see that it's really soft and it's going to come off on my paper. So let's put this aside, and so it says reaction to hydrochloric acid described. There was none, so I'm going to put an X. Striations. This does not have any striations on it, so I'm going to put an N for no. But I do want to show you, while we're looking at this, I do want to show you a sample that does have striations on it, and I don't know if you can see this if we hold this up close. In your book it shows a really good example. There are striations on this sample, and it looks like someone took and just made scratches down through here, but this is actually the way that the mineral is formed. And so this feldspar, this sample of feldspar has actually got striations in it, and some quartz does too. Hopefully you can see those striations in that sample. Okay, so cleavage, and in our sample I don't see any cleavage planes. If I can grab one of the other samples. This sample of mica, on the other hand, has got cleavage planes. As you can see, this piece has split apart. Those splitting apart layers, those layers that you can see, that's cleavage planes. So as you can see, that will actually split apart, just like that, and those are cleavage planes. Okay. This down, I'll put it. All right, so if none, we're going to put an X here. Fracture, on the other hand, is yes, and as you can see some fracture on this, the way that it's broken. Okay, hardness, tested and exact if on the Mohs scale. It's not on the Mohs scale, but you can test it, and if you'll go through and look at the testing samples, you can use your penny, you can use your nail, you can use your fingernail to see, and as you can see, this is pretty soft. So tested and exact if on the Mohs scale, and this is going to be 1.5 to 2, so it's very, very soft. Color, again, is going to be gray metallic. You can see it's very shiny. And so I've decided that this mineral name is graphite. Again, because of the testing properties, the chemical formula for graphite is C. It's made of carbon, just like a diamond is made of carbon. And the uses, you can use it in pencils to write with, and you can use it as a lubricant. And these uses are listed in your lab manual under each of the minerals. So that's one of our minerals that we've already tested, as you can see. And one of the other things that you can do is, whenever you're testing your minerals, you can get a magnifying glass and actually look at these up close to see what kind of properties that they have. Now then, one of the things I did want to show you, because our sample didn't fizz, it didn't react to the acid, is I want to show you one that does react to the acid. And get that one out so I can show you exactly what it looks like when it does react. All right, so we're going to look at this sample, and we're going to see if it's going to react. So we need our paper towel. Put our sample on our paper towel and make sure that you can see this on camera. And I'm going to take 1 drop of this hydrochloric acid, and hopefully you can see it is reacting very strongly. I don't know if I can angle that so that you can see that it's reacting. It's fizzing, it's bubbling. Let's see, pop it off and try one more time for you. You can see that that's fizzing and bubbling. And so that's a very strong reaction. Again, we're going to wipe this off. And one of the things I wanted to show you, this is a fossil piece of ammonite from West Texas that I found whenever we were out in the field. And ammonites are marine organisms, and they are also made of calcium carbonate, which is what is in the calcite, which makes it react to the acid. And you can see that this also reacts very strongly. See that bubbling that's going on there? That's a reaction. Also going to show you, this is an oyster shell from the beach that I found, and it's also made that same mineral, calcite, calcium carbonate, that this organism makes its shell out of, and you can see that it also reacts very strongly to this acid. See the bubbling that's going on there. So we'll wipe this off. So I hope that that shows you how to test your minerals, and you'll go through each one of your minerals. Make sure that you put a 1 here at the top for number 1. Make sure you put your lid back on your acid. Again, make sure that you wash your hands after you get through testing all of your minerals, and I hope that that helps you understand what you're doing while you're testing all the minerals in your kit. You have 30 minerals. There are extra pages in your lab manual, so don't worry about that. Just make sure you're filling in everything for all 30 of your minerals, and then make sure that you scan those and turn them in the assignment, and I'll grade them and get them back to you. Thank you, and if you have any questions, make sure you email me on Black.